All right. Everyone remember what a tangent line was? How many times does it intersect a circle? Once. When I draw a radius to the point of tangency, what happens? Perpendicular. If I draw two tangents to the same external point, what happens? They're congruent. Little review for Friday's quiz, which I'll talk more about tomorrow. What if I have a line that intersects twice? All right, we have a different name for that. Anybody want to try to pronounce that bad boy up there? Secant. All right, sorry, not secant. All right, secant. All right, that's a line, hits it in two spots. So you have a tangent that hits it in one, a secant hits it in the other. Our focus today, you're going to see more secants, but our main focus is going to be, how do I find an angle that's on the outside? So let's review real quick. If an angle's on the inside, it's one of three types. It could be a inscribed, could be a central, or a floater. All right, today, what happens if the angle's on the outside? All right, here's how we find it. So angle on the outside of the circle. And I don't care how it's formed. Everyone notice I have different types of lines up here, but angles B, A, and A in all three diagrams are going to be found the exact same way. How'd you find the floater yesterday? Because it's very similar to how you find a floater angle. How'd you find the floater yesterday? You took half of two arcs, and what'd you do with those two arcs before you took half of them? Added them. Today, subtract them. Okay, you're going to subtract it. So it's half the difference of its intercepted arcs. And we're going to go through each of these diagrams and figure out how to find it. All right, everyone wake up now. Here we go. Who's got 10? 10? Oh, you kids. I don't like you. 16? Are you ready there, Rico Suave? Angle B, how's it formed? By two what? These are what right here? Okay, so this is an angle formed by two tangents. Not off the hook yet. Angle B is the angle on the outside. So I'm going to take 1/2, and Andrew, you and I right now are going to subtract two arcs. The two arcs we're going to subtract are the arcs, when I say intercepted arcs, those are the ones inside the angle. Okay? Major minus minor, because if I do minor minus major, it's a negative angle. We don't want that. So what's the bigger of the two arcs right now that's in between angle B? CDA. Good job. CDA minus, what's the minor arc here? CA. Nice job. Next one, how is angle A formed? 4, how is angle A formed? Oh, easy, superstar. How's it formed? A what and a what form angle A? What's this and what's this? Oh, come on, you can just learn this one. Tangent and this is a chord, but now that I extend it, it's a line now. So it would be A, intersects the circle twice. Intersect secant, right? Tangent and a secant. All right, now go ahead, Skylar, and tell me how you would find angle A. I would take half of, which arcs are you subtracting now? Make sure the one's in between. There you go, BD minus BC. Excellent. Has the rule changed at all? Even though these two angles are formed in two different ways, has the rule changed? Absolutely not. As long as it's on the outside, we're going to do half the difference. How is angle A formed in the third diagram? 8, what do I have going on here? Usually, yes. So I'm not fired up about that one. I'm not. I had to think for that for a second. 28. 2 secants. What do you think here? Angle A, take half of what there? There you go. No matter how it's formed, if it's on the outside, rule is still the same. Rule is still the same. You guys have any questions on how to find these? Because now I'm going to show you two special type of angles now, which some of you may have wanted to know on your homework, would have made it a little easier. What about an angle formed by a tangent and a chord? All right, an angle formed by a tangent and a chord. Specifically for us here, the measure of BAC. And can you guys just put a random point D on here? Because we're about to use an arc. We need to name it specifically. All right, why is this a little different? Well, guys, is this inside the circle? No. Is it outside the circle? No, it's on the circle, right? But is it inscribed? And this goes back to Skylar's question, so hopefully you were paying attention. Is that an inscribed angle up there, BAC? No, because the two sides are not chords. So it's kind of like one of those, I don't know, I don't want to say weird angles, but special angles, right? It's not inside, it's not outside, and it's not an inscribed. All right, so here's how we find an angle formed by a tangent and a chord. It's half its intercepted arc. Even though it's not called an inscribed angle, we still find it like it's an inscribed angle. So BAC, I would take half of which arc? Angle BAC. What arc is created by BAC? Arc AB. Yep, that's why I had you put that D on there, because if I said arc AB, which one are you talking about? So I would take half of 140, 70 degrees. So a little special type of angle right there. It's not inside, it's not outside. Oh, I'm not done yet, champs. Settle down. You're drawing yourself another text box right now. Because there's one more special angle I have yet to talk about. Probably going to regret this. Not yet. Here's what I need you to do in your group. I've given you an angle formed by two tangents, a tangent and a secant, two secants, a tangent and a chord. There is one combination I have not given you yet. Can you figure out what that combination is within your group right now? All right, there's one. Just so you know, yesterday we did two chords. All right, that's the floater angle, is two chords. There's one combination we have not talked about, an angle formed by a blank, blank. All right, see if you guys can figure out what that combination is. Any group find out what that combination is? What's the combo I have yet to discuss? What do you got, Saad? There you go, stud. Angle formed by a chord and a secant. So let's draw that right now. And let's talk. Okay, so I know my secant goes through twice, and I know what a chord looks like. So there's a chord and a secant. Make sure you know what angle I'm not talking about this angle, because what type of angle is this one already? That's an inscribed, so I'm not talking about that one. I'm talking about this one right here. That's the angle formed by a chord and a secant right there. And you're going to be shocked by what I have to say now. You are not going to take half the arc. Is that inside? Is it outside? It's on the circle, but is it inscribed? Okay, so it's a special angle, but it's not half the arc. Everyone ready for the rule? I don't have one for you. I don't have one. There is no rule to find that angle. You're not taking half the arc. You're not adding two arcs and taking half of it. You're not subtracting two arcs and taking half of it. There is no rule. But does that mean it's impossible to find that angle? No. Anybody got a little system to find that angle? What do you got for me, Rose? find the inscribed angle next to it, and it's supplementary. Okay? Everybody good? All right, so I don't have a rule, take half of this, half of this. There's no rule for it, guys. But just realize it's not impossible. You can easily just find the angle next to it and subtract from 180. All right? All right, let's put in some work. I'm skipping over one because we just did that with the chord and the tangent. Okay, find arc AB. Here you go. I'm just going to specify directions here. Minor arc. I'm looking for minor arc AB because there's two arc ABs on here. So I'm looking for minor arc AB. $12. Who's got 12? All right, Frank, here you go. That 160 that they gave me, I'm going to start rolling through these angles in my head. Is it inside the circle? Is it outside? Okay, it's on the circle, but is it inscribed? No, but it is an angle formed by a what and a what? Tangent and a chord. So where did that 160 come from? I took half of whatever the arc was. Okay, so we could do this one of two ways. You tell me how you want to do it, Frank. I could label that arc, or I could find the angle next to it and find the arc I'm looking for. Okay, so if that's 160, what's the supplementary angle to it? 20, and that's also an angle formed by a chord and a tangent. So do you want me to take half of 20? No, I found this angle by taking half the arc. So what do you want me to do to 20? Double it. So 20 times 2, that arc's 40 degrees. Chord and a tangent is half the arc. Questions? All right, let's keep this train rolling. Who's up next? 14, 14, 14. Hi, Nate. You all right like that? Keep turning around. Don't you want to turn the desk or no? Where floats your boat? Here you go. 3. Angle X. Ready? Inside the circle. Nope. Outside. All right. Discussion's over. It's outside the circle. I know the rule is going to be 1/2 the difference of two arcs. Nate, tell me what arcs are in between. What are the intercepted arcs there? 90 and 20. There we go. Angles on the outside. I'm done talking. I know I have to subtract 2 arcs and take half of it. Half of 70, Nate? 35 degrees. Nice job. I'm going to need a stud for this one. Let's see if the random generator can feel it. 7. Okay. Here we no. Never mind. You ready? I'm okay with you doing this one, Evan. I got some faith in you. Okay. See that 38 degrees they gave me? Inside the circle? Outside. Okay. So how did I find it? I did 38 was equal to half of 2 arcs added or subtracted, Evan? Subtracted. And I already know what the minor arc is that I'm going to subtract. And what's that? X. Here's the issue you and I have and the rest of your classmates. I have no idea what that major arc is going to be that I need to plug in. Because you can't do 360 minus 140 because you still have that arc there. All right, you ready? I know that arc is 140 that I gave you. How many degrees are still left over for the entire circle? 220. Everyone agree? 220 is left over for those 2 arcs. Well, you already told me that one's X, and there's 220 for the whole thing here. So how can I express this arc, major arc? Got it. 220 minus X. And that's what's going to go in here. 220 minus X. Everyone okay? Safe on that? Tell me now. And just like I did yesterday, I am going to get rid of the 1/2 by multiplying both sides by 2. I did this yesterday. Multiply both 38, 76. Move everything around. Evan, when you're ready. Yeah, buddy. Any questions? Sure. 8, you're on deck. You sure? You need any more explanation?
Yeah, I just didn't do the math.
Okay. We all right where everything came from up there, what I set up? Good, Julie? Okay. Oh, not here. It would have been worthless anyway. 3. Too harsh that he's not here. 3. You ready, Rose? You can handle it. 60, inside or outside? Perfect. So I know I'm going to subtract 2 arcs. You already know what the minor arc is. That's x, so something minus x. What about the major one now, which is the rest of the circle? Oh, no. This is the angle. This isn't part of any arcs. So this is x. So the rest of the circle would be 60? How many total degrees am I going here? 360, right? This is x already. So the rest of it would be 360. Oh, I thought you said 60. I'm sorry. That's my fault then. Old age and hearing, I guess. Everyone all right there? All right. Get rid of the 1/2 for me. 120 equals 360 minus 2x. Whenever you're ready there, Rose, just let me know. Thank you. Nice job. So we okay there before we get to a big dog question? Here we go. A little peel. Big dog time. What do I have there? 1, 2, 3, 4, 5, 6. Oh, 6 people here. All right. CD's tangent. Got it. Circle O. That means the center's O. AB and AD are congruent. I wonder why they told us that. AB is 150, so the measure from A to B, and I'm going to let you know it's going that way. I should have put an E in the middle, I know. Should have put an E in the middle. Chord EOD is a diameter. Find a bunch of arcs. Guys, here's what I want to focus on first. Why in the world did they tell me that AB and AD were congruent? Because that's going to be a big piece here before we start. 18. Hi, Matt. Can you please identify what AB and AD are in the circle? What do I call those pieces in the circle? What is AB in there? Segment, endpoints around the circle. What do I call it? Those are chords. Everyone agree? 2 chords are congruent. A theorem we went over maybe day 4. If the chords are congruent, that implies what? If the chords are congruent, that implies the arcs are congruent. Yes. All right. So which arcs in particular, if AB is congruent to AD, which arcs in particular are congruent? Well, let's see. Which arc belongs to AB? That would be AEB. Congruent to which arc belongs to AD? Arc AD. Congruent chords imply congruent arcs. Why is that important now? What is the measure of arc AD then? Here you go, 7. What's the measure of arc AD? 150. If you guys remember from yesterday, if you know the arc measures, these big dog problems are simple. Don't look at parts A through F yet. Can anybody find the remaining arc that I don't know, BD? And then I can go on my way. You want to take this side? And an explanation to your classmates. It's 60. Why? Yep, I already have 300 degrees out of 360, so that means that last one has to be 60. All right, so I don't need to call anybody for part A. That's 150 degrees. Everyone ready? BAD. Who's up? 7 again. You're on fire back there. BAD. Inside the circle? Yeah. Nice. Central? No. Inscribed. Okay. We've identified it's inscribed, so I'm going to take half of the arc. Evan, what arc is BAD drawn to? Which is a measure of 60. So BAD will be 30. And just like I said yesterday, you may want to plop it in there. You may need it later on. Who knows? Good job, Evan. 21. Here we go. ACD. Inside, outside. Discussion's over. What am I going to do? Add or subtract the arcs there, Luke? Okay. Now the tough part for you is what two arcs? Nice job. 150 and 60. The arcs in between. 150 and 60. What do you got for that angle measure? 45 degrees. Bless you. So that's 45. $14. Are you ready? EFB, inside or outside? Central, inscribed, floater. What do you do to find the floater angle? Add or subtract the arcs? Okay, Nate. Name the arc that EFB creates. Ooh, EFB, what arc? It's EB, right? But I know all of this is one. Can you find what EB is? What's this again? This is a what right here? No, just this EOD. Diameter, that's a half circle, right? If that's 60, this will be $120. Nice job. Everyone all right? 120, which is the one arc I'm going to add to. It's vertical angles arc. 150. Yes? No? Ask. I hear some. We okay? 60, 120. Okay. What do you got for me when you're ready, Nate? 130. 135. Yep. Are we all right so far? This is, again, keep asking these darn questions in your mind every time. 7, here we go. EDA, inside, central, inscribed. Ooh, problem. Yes, it's inscribed, but I don't know the arc that it's drawn to. It's blank. Can you find it, though? What's that arc? How do you know? Just a couple ways how you know.
150 minus 120.
Yep, these two arcs add to 150. I already knew that's 120, so that's got to be 30. Half of 30, what do you got for me? 15. And we're going to finish this off right now. 22. Hi, Joanna, how are you? Usually part F, that's the hardest one, right? EDC, do you see that angle, EDC? Is it outside? Is it inside? Ooh, it's one of those special angles, isn't it? Because it's formed by you could say a chord, a diameter, and what did we say CD was? A tangent. You remember that special, how we found that one? You took what? A chord and a tangent. Oh, you're going to do it that way. That's fine. I was going to ask that at the end, but yeah, that's a point of tangency. Radius drawn to a point of tangency is perpendicular. The other way, it's half the arc. Everyone agree? You could also do it that way. An angle formed by a chord and a tangent. Take a look before we finish. Angle formed by a chord and a tangent is half the arc. What's its arc measure? It's a half circle, right? So you could have taken a half of 180 too. But that theorem is awesome. Radius drawn to a point of tangency is perpendicular. Yep. Questions at all? Yes, Evan.
So that last one, could you just say that CFD was 45?
Yep. And do a 45, 45, 90? Yeah. Yep, pretty much. Yep, there's another way. All right, nice job. Just a reminder, summer, there's 2 questions in the packet next page, and the rest is out of the book tonight. I don't think I assigned a review problem.